the way Zoom behaves, that it cuts off even when people are still reading. But I think maybe for our friend who joined that first, so I was just texting in the group that she can rejoin. She can use the link again to rejoin. So, like I said again, we need to make sure that when you are reading the question, read it as slow as possible. One sentence at a time, one line. When you hear the word a record skiing speed of 203.1 kilometers per hour. Okay, you have been told the speed there was achieved. All right. So, yeah, this record speed was achieved. So I'm sure you, I don't know if you guys have seen the Olympics before. There are those skiers who slide down the mountain. Are you guys familiar with skiing or skiing? Have you ever seen skiers? This word skier, skiing. Have you ever come across such?
No.
Mr. Gilbert, have you ever seen a skier or skiing? Have you ever heard that word skiing?
Yeah, I've just heard about it, so I don't know its meaning.
Florence, are you familiar with a skier or skiing? Have you ever heard of skiing? Florence, are you with us? Okay, maybe she's cooking. But quickly, skiers, how many of you guys were young? So to say, let me ask, how many of you guys were young at one point and you used to go on top of a hill, all right, either get a container or bananas, you know, those banana trees, and then sit on them and then start skidding down the slope? How many of you guys did that? Eesh. Children of nowadays, you didn't play like we used to. Mr. Gilbert, you never did that.
No, at our place there are no mountains.
So you guys never did that. I mean, Chipo, or maybe Precious, you guys never went to the mountain. You sit on a banana tree. Oh,
No.
Chipo, you never did that.
Yes, I've never.
Or you never saw people doing that.
I have.
Precious, did you do that?
No.
You guys are disappointing me. You guys were not young at one point. In fact, I think for me, even girls, okay. It's across all genders. It wasn't a segregation of the only boys would do that. We used to go on a hill, and we used to come back with the, you know, most boys used to put windows on their back. Their buttocks used to come with windows because their shorts were torn because of skidding down a hill. So this is also what is happening. It's actually a sport, and people are talented in doing that. In other countries, you get money to skid down a mountain and skid down, achieving even such a great speed. So usually what they do in Olympics is that instead of sitting, as we used to sit down on a banana tree and start stopping down, then they have some equipment that they have specialized, and what they do is they skid down while standing and pushing themselves, skidding down a mountain, and it's covered by snow. Usually it's covered by snow, so it's very slippery. So as they are skidding down, and these people are called skiers, all right? So, and this mountain or this slope is inclined at 51 degrees. So now they are saying at this speed of 203 kilometers per hour, at this speed, the air friction and the force of friction, the air resistance and the force of friction is balanced. at this speed, the force of friction and the force of friction on the skier, which is the air and sliding friction, balances the pull of gravity along the slope so that the motion proceeds at a constant velocity. You know that if a motion is going at a constant velocity, meaning the net force is zero. So when you reach at this velocity of 203.1 kilometers, you reach at a velocity called terminal velocity. Terminal velocity is where you reach at a point whereby your velocity no longer increases. The air resistance and the force of gravity, they are balanced. So there's no friction, there's no net force. All right. So you get that concept, you put it in your head. Once you read, you get some concepts, you put them in your head. And then you got the first question, which is saying, what is the rate at which gravity does work on the skier? All right, what work does the gravity does work on the skier? So you assume that the mass of the skier is 75 kg, as they have told us. So this is question 1. And then question 2 is saying, what is the rate at which the sliding friction does work? So we also have sliding friction doing some work. Assume that the coefficient of friction, sliding friction, is what we have here. What is the rate at which friction, which is air friction, does work? So these are the questions that we have. Let's see how we can look at the solution. So this is the diagram. So as in our case, we used to sit down, but this guy is standing up and then he's skidding down this mountain. All right, this is a skier for some of you guys who have never seen him. Say hi to Mr. Skier. Anyway, yeah. You guys, this is what they are talking about. And the data that we have is that the velocity that we have been given, the maximum velocity that we have here is 203.1 kilometers per hour. The angle here is 51 degrees and the coefficient of friction is 0.03. So the first question is saying, what is the rate at which gravity does work on the skier? All right, so maybe someone to give us some thoughts. How can we compute the work which gravity does on this skier? Someone to give us some thoughts. How can we go about this question? And the first question, how?
So, okay, so let me just try.
Awesome, awesome.
We're looking for work, right?
Rate at which,
Yeah.
they're saying rate at which gravity does work, rate of work.
The rate of work is the same as power. Yeah, since in the question, in the data, we've also been given the, is it the velocity, which is 203.1. Yeah, we're supposed to convert that to meters. Then the time which you've been given here, it's 1 hour. Then you convert the 1 hour to seconds. So to be 60 times 60, will come up with the time in seconds. Then that times 1,000 will come up with the time in the distance in meters. Then after that, you find that will be force, and force will be, then you find the force using the kgs, which the mass, which is, then you find the force, which will be the mass that you've been given times the 9.8, will come up with the force. Then you multiply it with the force that you find here, the velocity that you find here.
Awesome, awesome, awesome. Good thoughts, good thoughts. I like your thoughts. They are very good thoughts. And these thoughts are, such thoughts are what give people A pluses in exams. Okay, only that you missed it at one point. You need to draw your free body diagram. I always emphasize you guys should be able to draw a free body diagram. So this is my redrawing of the skier. Now on the free body diagram is where you see forces, which force is applying where. All right. So Precious told us that we need to compute, the force will be the weight, which is mass times acceleration due to gravity. But we see that this is not the force that we are supposed to use, because this force doesn't do any work. All right, because this guy is not falling vertically. So if this guy was falling vertically, we would have used this force. So we use the force that points in the direction of motion. All right, that is parallel to the direction of motion. So the force that is parallel to the direction of motion is this mg sine theta, sine this angle. We realize that in this direction, the force of gravity will have its component. That's why we're saying here, this is our force of gravity, but our force of gravity of a component in this axis, and this will be actually what we are saying that we will define our axis in such a way that this will be our y-axis, and then this will be our x-axis. All right, so this will be our y-axis and this will be our x-axis. So if we are given the angle like the way the angle is given here, all right, so this way to have a component in the y-axis and the component in the x-axis. Here we are at liberty to define our x and y-axis. We have rotated our y-axis like this. It's also diagonal like that, and our x-axis is slanting like that. So meaning we'll use this force which is parallel to the direction of motion. All right, so we'll use the component of gravity which is parallel to the direction of motion. Therefore, we will not use mass times acceleration due to gravity just like this. We'll use its component in the y-axis. So therefore, in our calculations, we know that gravity does the work by pulling the slide to the bottom of the slope. But since it's at an incline, since the incline is at an angle, gravity also works at an angle throughout the motion of the slide. To find the rate at which gravity does the work, which is power due to gravity, we need to compute the following. Power due to gravity will be equal to mg sine theta, because mg sine theta is parallel to the direction of motion. So that is what we use as our force. And then we multiply the velocity. In fact, power is equals to force times velocity. That's another formula for power. Power is force times velocity, because in velocity there is distance and time. All right, so we see that we get our mass multiplied by 9.8 sine the angle of the incline, multiplied by this. Actually, this is supposed to be 0.1. Yeah, 0.1, yes. Multiplied by this velocity, which is 230.1. All right, it is kilometers per hour. But these kilometers per hour, how do we change it? How we change kilometers per hour is kilometers is 1,000 meters. This is the conversion. Kilometers, 1,000 meters over kilometer, meaning 1,000 is the same as 1 kilometer. So meaning here, this is what we call multiplying by a special one. All right. We are not changing anything. We are multiplying by a special one. A special one is 1,000 meters over 1 kilometer. So this is the same thing. This is more like just writing 1. But then this kilometer and that kilometer cancels. So we would have converted into our meters like that. And then also we realize that our hour is the same as 360 seconds. All right, seconds. 360 seconds is 3,600 seconds. Yes, that's our hour. So we realize that using this conversion rate, we can change what was in kilometers per hour into meters per second. And then when we compute this, we can be able to find our power done by gravity, or the rate of work which gravity does is computed like that. So that's how to go about such a question as that one. Are we okay, friends, with the solution? Are we following?
Yes, sir.
Yes.
Okay, so we have seen how, as I will say again, that when you are computing work or power, the force that you are supposed to use has to be parallel to the direction of motion. So you can't use normal force to compute power. You can't use this normal force. You can't use this weight. This weight, you need to convert it into its x component, which is parallel to the direction of motion for you to compute your power. All right, so we go to the next question, which is saying, what is the rate at which the sliding friction force does work? Assume that the coefficient of friction is that. So to find the rate at which, find the rate of work done by friction force, we need to find the normal force by summing the forces in the y-axis. Why are we finding the normal force? Is because we know that friction force is the mu times normal. The coefficient of friction times normal, that's how we find the force of friction. So we need to find this normal. And in this case, we see that summation of forces in the y-axis, we have the normal force pointing up, and then we have this weight, mass times acceleration due to gravity, pointing down, but it's at an angle. All right, it's at an angle. So now this, we learned through SOHCAHTOA that to find the component of this weight in the y-axis, we use cosine function, because the angle is taken with respect to the y-axis. So since the angle is taken, this theta, which we have put here, theta, mind you, this theta is equal to that theta using the properties of angles, such as alternating angles or opposite angles like that. We see that this angle is also equal to that angle. And since here this angle is taken with respect to the y-axis, for us to find the component of this weight in the y-axis, we'll use the cosine function. So we see that when writing out our equation, we have the normal force, which is pointing in the positive y-axis, and the friction and the weight, the component of it, we have used cosine function because the angle we took was taken with respect to the y-axis. And then we are putting a negative because it is pointing towards the negative y-axis. And then we see that when we compute this, our normal will be equal to mg cos theta. We know our mass, we know our gravity, and we know our theta. When we compute this, we find our normal force. But we have not finished there. To find our friction force, we use mu, this is the coefficient of friction, multiplied by the normal force. And when we compute it like that, we can find our friction force. Now, once we find our friction force, we can now compute the rate at which the friction force is the rate of work done by the friction force can be computed as follows. We know that rate of work is power, and power is also computed as it's also computed as force. This is the force multiplied by velocity. So force multiplied by velocity, we can be able to find our power. We have our force here, and this is the velocity in kilometers per hour using the same conversion that we used. All right, 1,000 meters over 1 kilometer multiplied by 1 hour over 3,600 seconds. We can cancel out this kilometer and that kilometer, that hour and that hour cancel out. Then we'll remain with our answer in meters per second here. Our velocity will now turn into meters per second. When we multiply it by the force, we should be able to get our answer. This is supposed to be in joules. Power is supposed to be in joules per. Okay, let me just show it properly. Okay, so I'm saying our answer is supposed to be in joules per second because we are told to say the rate of work. Rate is the same as power because this is the same as watts. If we wrote watts or joules per second, it would be the same power. All right, the rate at which work is done. Yeah, so we are here. Are we following so far?
Yes.
Yes.
Are we all following? The others are not saying yes. What's wrong? Are we following? Chipo, Florence, Gilbert?
They're following.
Yes, sir, I'm back now.
Oh, you went somewhere.
Yes.
Okay. I hope you'll be able to catch up on where we are. But again, like I said earlier on, I'll post this video on YouTube and send the link to you guys in the group, and hopefully you guys can be able to watch it if you want some clarifications or if there are some points where you missed. So we are continuing on, and part C is saying, what is the rate at which air friction does the work? All right, what is the rate at which air friction does the work? All right, so we need to find this force of air, this air friction. For us to find out what is the rate at which air friction does the work, we go back to our free body diagram. On our free body diagram, we indicated some forces. We had mg sine theta pointing in that direction, and we had friction force opposing the motion. Also, we had the force due to air resistance opposing the motion. And since they told us that at this velocity, in the question, they told us that at this velocity, the velocity becomes constant, meaning when we add these forces together, they should give us a zero, because when the velocity is constant, meaning the net force is constant. We know mg sine theta, we know friction force, so we can be able to find the force due to air resistance by adding these forces and equating them to zero, because we know that the net force is zero when the velocity is constant. That is what they told us in the question, that the velocity will proceed at a stable, the velocity will be constant because the force of friction due to air and static friction and sliding friction will balance up, will equal the weight or the force due to gravity. So let's see how we can implement this in our equations. All right. So in this case, since we have been told that the speed is constant at 203.1 kilometers per hour, so we know that the net force is 0. So we have the friction force and the force due to air resistance minus mg sine theta. Why have I put this one minus and these positive? All right. The reason why I've put these which are pointing upward like that, the friction force and the force due to air resistance to be positive, it's a choice. All right. As long as these ones are pointing in one direction and this other one is pointing in the other direction, you can choose this to be positive and that one to be negative. You can choose this one to be positive and that one to be negative. It's a choice as long as you stay consistent. So I can't pick friction force to be positive and put air resistance to be negative because these forces are pointing in the same direction. They should have the same sign. So no wonder I consider them positive because they are pointing in the same direction. And then this other force, I considered it negative because it's pointing in the other direction. All right. So no wonder I've put friction force plus air resistance. These are positive forces. I've put them as positive forces. It's a choice. You can want to put them as negative forces. It will also be your choice. All right. As long as these forces and this force have a different sign because they are pointing in different directions. So we have friction force and air resistance and then subtracting mg sine theta. Again, the net force has to be equal to 0. So using this, we can find our force of air resistance as mg sine theta minus the friction force. It is just taking this one to the other side and also taking to this other side and making force of air resistance as a subject of the formula. So I don't know what happened here. We're supposed to have the actual value. I computed the actual value. I'll show you, I'll put it properly when I'll be sending in the notes. I actually replaced the mass, the acceleration due to gravity, and the angle. I replaced them properly, and I solved it here. Otherwise, when you compute this, the force of air resistance, you will find it because we need, the question is asking us to find the rate of work done by air resistance. So we compute the following. Power due to air resistance is force due to air resistance multiplied by velocity. If you compute this, this is the force of air resistance that you find, multiplied by your velocity, like that, like we did in the last time. This is the conversion. So we have 203.1 kilometers per hour, and this is the conversion rate to change it from per hour to per second, meters per second. This is kilometers per hour. This is how you change it into meters per second, like that. All right. I already explained how to go about this. So once you compute this formula like that, you'll be able to find your power due to air resistance. All right. This, you can either write it in watts or in joules per second. The rate of doing work is the same as power. So we have looked at some interesting questions in the tutorial sheet. All right. Like I said earlier on, the theory sheet is there to guide you even how to study. If you can solve the questions in the theory sheet, even what you're studying will be guided because you will not study more or less. So study mostly what is given in the theory sheet. If you can manage to solve that question in the theory sheet, then you are home and dry. Some of you guys have a tendency of solving or reading books just like that. You will find in books that a lot of information. Now that information may not even help you in this course, Physics 1010. So the syllabus for Physics 1010 is outlined in the theory sheet such that when you solve the question in the theory sheet, you get a good understanding of the course on that particular topic. So we have solved some questions in the theory sheet, but I would encourage you to solve the whole theory sheet on this particular topic. Otherwise, we have a homework, which I would like you guys to do. Now, this question is on the same topic that we have looked at. This question is from an exam. If not in a test or an exam like that, this question is an exam question. So if you can solve this one, then you know that you are able to solve exam questions on this particular topic. So I would expect the solutions to be used to send me the solution either by tonight or tomorrow before we meet again on Thursday. All right, because our next class is on Thursday. So this is one question. And then we have another question. This other question is from the theory sheet, but this one is from the homework. So if you can solve these two questions, I'll have confidence that you guys have understood this topic. So yeah, otherwise, do we have any questions on what we have learned today? So Precious, are you okay with what we have learned today?
Yes.
Awesome. Chipo, are you okay?
Yes. Yes, sir.
Okay. Florence, are you okay? Have you managed to grasp something on what we have learned today?
Yes, sir.
Mr.
Though the
Gilbert,
time wasn't okay.
though the time wasn't what?
Okay for me.
Okay. Which time do you suggest is best for you? In the morning, for
10
example,
or 16.
10 or 16.
Yes.
So I'm sure we can further discuss it in the group if we can be meeting at 10 hours so that all of you guys are able to appreciate and have no discrepancies. So Mr. Gilbert, you're okay?
Yes, sir.
Awesome, awesome. So like I said, what we do here in physics and the ideas that I give you guys are there to open up your mind. All right. So I'm here to open up your mind so that even when you find a question which is very different from what we have looked at, but these skills of problem solving, the skills of problem solving that I'm giving you should be able to give you the power and the confidence to attack any question and apply logic to it and then manage to actually solve it. All right. So these skills that I'm showing you are there to equip you, give you that power to be able to look at a question with confidence and then solve it. You know, even these skills are also the skills that you would need in life. All right. In life, you have to have some sort of power to be able to solve problems in life. You have to have a mind which is always thinking analytical. All right. Maybe I can give an example. You know, some of you guys get to you meet a question for the first time in the test or in an exam, you get to panic. How can I go about this question? All right. That is going to defeat you right there and then. Even if you are meeting a question that you have never seen, you have to attack it with an analytical mindset and use some of these tools that I'm teaching you. Even in life, if you encounter a situation that is disturbing and that you feel like you don't know what to do, don't panic. All right. So I can even give an example of, for example, some of you guys who are dating, you find your boyfriend or girlfriend with another person. All right. Do you panic to a point where you even get a knife, you kill someone, whatnot, or you kill yourself? No. All right. You guys have to possess a calm mind. When you see a problem that you can't solve, right there and then, try and read through, even in life. You meet a situation that you don't understand properly, try and understand what is happening. Maybe that person whom you have found your boyfriend with is the sister or a cousin, and you are just overreacting, all right, because you were acting on impulse. Also, even a question in an exam, maybe the question that you're looking at, which you think is difficult, is just a simple question. If you calm down and think through, you can manage to solve. So I'm not here just to teach you physics, even to give you tips on life. I'm here, and yeah, so let us keep the conversation going and solve my homework. I'll post it on YouTube. You can watch it again if you wish. And yeah, I guess that's it for today. Have a good day. You guys are not wishing me